Okay, thank you very much. So I'm going to talk about the Copernicus Climate Change Service, C3S for short. It's mentioned in the roadmap. It is a major initiative of the European Union. It's funded by the European Union, and it's being implemented by ECMWF, the European Centre for Medium Range Weather Forecasts. And the talk is really connected very strongly to the roadmap. It's the Climate Change Service, C3S, is very much an opportunity for the growth of a climate services market. I should say that the head of the C3S, the head of the Climate Change Service, is at ECMWF is Jean-Noël Thibault, whose name is on this slide, and it's to him that you should contact and address further comments and questions after the meeting. So C3S, as I say, is a new program, just started, and this is its mission for the next 6 or 7 years. It's to be an authoritative source of climate information for Europe, covering both past climate and trends in past climate, the current state of the climate, and projections of possible scenarios in future climate. It's very much a global perspective. Of course, Europe is a critically important part of the globe, but all I'm going to talk about in terms of information that's going to be available through C3S will be global in content as well as specific as well for Europe. C3S is not going to duplicate what's already there. We already exist in a complex scenario of efforts across Europe in this space, as we've heard of this morning. And our intention is to build upon national and international existing efforts. And finally, in terms of the mission, as I've already said, it's very much linked to the roadmap to support the market for climate services in Europe. And I want to refer to that a little bit later in what I say. The key words on this slide is that C3S is going to be aspiring to be an authoritative source of information. We've talked about this morning how critically important trust is in climate information. You can look on the internet and get as much climate data as you wish from thousands of sources. And it's really important now, I think, to understand where to go to get the quality information that's scientifically credible and at the highest quality. And that's really what C3S is there to do. So these are the sorts of questions that this climate service is going to be addressing. And just before I go on to this, I should say it was obvious this morning that the term climate service is used for lots of different activities. And the way I tend to think about this is that it's actually a pipeline from quite high-level scientific information, observations, right through to end users' interpretation of information, even within companies or businesses. And the term climate services is often used right through that pipeline for different ways of which that information is developed. So I think this is potentially a confusion that we will need to cope with and to manage in the future. But the C3S is aiming to look at these generic questions in climate change. How is the climate changing? And for that, we're going to use and bring together Earth observation, satellite information, and in situ information, and also what are called reanalyses, which are ways in which that information is drawn together to form a consistent picture of the Earth's climate. And this is an opportunity for me to note that Copernicus investment by the European Union is also in a massively big program of new satellite measurements about the state of the climate. In the Copernicus program of Earth observation satellites. And the first one has been launched, and there's a whole sequence actually spanning out for the next 10 to 20 years. And that's going to be a really important additional data set to determine a number of factors, including how climate is changing. The second important question is, will climate change continue, accelerate, decelerate? And for that, we need to draw together the best quality predictions and projections of climate change. And again, in Europe, we're in a good position because scientifically, we've got some of the best expertise across Europe in this area, across the world. And then finally, the third generic question that we want to attack in this C3S is what are the societal impacts. So to develop specific climate indicators relevant to particular sectors that will be used during this pipeline, ultimately to have tailored information for individual companies and businesses to use. So this is just an example, I hope you can see it, of what I was talking about with reanalysis. I just wanted to give you a couple of examples of the sort of information that will be coming through. This is a global map on the left of the state of the climate in 2014. It is the global warming signature, if you will, and the red colours represent where the globe was warmer than the average over 1981 to 2010, and the blue areas are where it was cooler. And by using all of the observations, satellites, thermometers, wind observations, all of those measurements, we can get a complete picture of the state of the climate. This is actually the temperature near the surface, but we can also describe other properties of the climate system. And 2014 was one of the warmest years. The reanalysis actually didn't show it was the warmest of the record. And on the right-hand side is the reason. Actually, the signal over the Arctic, which is the top right-hand circle, the Arctic was considerably warmer than the average over that period. But actually, the Antarctic was quite a bit cooler in 2014, and that changed the global average. So it's a reminder that global average temperatures are one thing, but they're made up of quite a regionally diverse set of information. And this is the sort of thing that we want to continue to refine, because we really do need to know what globally and regionally the climate is doing and has done in the recent past. Another sort of output that will be in the C3S service is a range of predictions and projections of future climates. And that's not just 50 or 100 years ahead. That's also from timescales like the seasonal timescale. And this is actually a seasonal forecast already for Europe from a consortium of models for May, June and July, for this coming May, June and July, showing red areas where the surface temperature is warmer than normal for that time of the year, and blue areas where it's cooler. And this is very topical at the moment because we're looking like an El Nino is developing in the tropical Pacific. This has global impacts on the weather and the environment across the world. And one of the key questions for European climate in May, June and July is actually what's happening in the tropical Pacific in El Nino. And that looks like it's developing. We don't know for certain yet. It will also have an impact, El Nino, if it does develop strongly, on the global warming signature. So it's a reminder that all these timescales are interacting. It's not just a local problem, but it's also a global problem. C3S, how is it organized, to come on to the service in particular? It's got 4 components. It's going to be a climate data store, drawing together all of this authoritative source of information into one location, distributed sources of data, but a consistent data store for people to use. I should say at the start, all of this data will be freely available to anybody. So there's no issue about payment there. The second area is a sectoral information system. I've got a slide on each of these coming up, where we actually will be looking to demonstrate how this sort of climate data can be used in a variety of sectors of the economy and society. And I've got a couple of examples to show. This is really where the handover is also to the private sector, because companies will be able to develop value-added, tailored products and services themselves to other users using the basic information that's freely available in C3S. So one of the outputs of the Copernicus program is to generate jobs and business opportunities for companies, small companies as well, to prepare that kind of value-added information. The third area is outreach and dissemination, which is really critically important to get the message out about this data and how it could be used. And the fourth area, last but absolutely not least, is evaluation and quality control, because, as I've said, the trust in these data is really fundamentally important. So the climate data store will be based around drawing together a whole series of information, which in the business is generally referred to as essential climate variables, which are the aim is for these to be long-term data sets that are continuous and reliable over a period of time. It includes surface air temperature, precipitation, greenhouse gases, ozone, aerosol, sea ice, sea level, many aspects of the climate system, and also a set of indicators of change associated with those variables. And that will be done both by using observational data, but also by these reanalysis data and also simulation data. And this will support adaptation and mitigation in Europe. And we will also be looking at, in that data store, as I've already said, in forecasts and projections. The evaluation and quality control is really important, and to make sure that this is a trustworthy and credible, scientifically at the highest level, state-of-the-art, as it says here, climate information for users. It will also identify gaps in the service, and this is an important part of today's meeting, because these services, this is an operational service, C3S, but it does have to benefit from new research that's being done, not within this service, but by Horizon 2020, to draw that information in. And this evaluation components of the C3S will identify gaps and where we need research results to come into the service. The sectoral information system will look at a number of sectors to demonstrate how this kind of information will be used. Two of those that we're going to start with will be on water management. It won't surprise you, on water management and energy, and these are some pictures from the European Environment Agency on water stress in the future climate, and also energy resources from solar radiation in the future. Outreach and dissemination is critically important. The cartoon on the right is absolutely spot on. 2,500 scientists agree, but someone wants a second opinion. We know from the climate change agenda that we can't talk enough about what this information means with a whole range of users and people in the outside of the scientific community. I just want to have one slide, because I think it's really important for this meeting, on what research is needed in the future to enhance the climate change service, C3S. Uncertainty in this information is going to be really important. And within the data store in C3S, there will be very strong emphasis on quantifying the uncertainty associated with all the information. But we also want to reduce that uncertainty, and that's where the research comes in. And we really desperately need research. Horizon 2020 can be funding this as well, on seasonal and decadal predictability, what determines those ranges of predictive skill on the climate system, how to couple the atmosphere and the oceans and the land surface to get a consistent picture of the state of the climate, on Earth system modelling, because we're on a journey to make these models much more complete in terms of how they describe the whole Earth system and not just the atmosphere or the oceans, for example. And then finally, but not least, the socio-economic research that's needed associated with this. And these are really important research areas that I think need to be supported through Horizon 2020. And my final slide is a summary. So what I hope you will get from what I've said is that C3S, which is implemented by ECMWF, is going to build on the national capacities. It's not going to duplicate. It's going to draw together observations, infrastructure and existing services, and also the outcomes from previous and current EU-funded R&D projects in climate change. It's going to complement and enhance these capacities to operationalize the service. So this is an operational service that will be there for the longer term and can be trusted and counted upon. And it's there to help develop markets, as we've heard, by providing data sets, tools, and best practice. But it needs the supporting research and development to make it state-of-the-art, because there are still huge uncertainties in a lot of this climate information. We heard this morning about site-specific information needed. The uncertainty at the moment in the future climates on site-specific information is huge. So we really need research to help narrow that down as far as possible. So the timeline for the C3S service is that we're going through the next couple of years, ramping it up in terms of a proof of concept and pre-operational phase, but there will be opportunities to get involved in procurements of inputs to the service in that period, and then we go into a full operational phase in 2018 onwards. And if you want to know more, this is the website to go to, www.copernicus-climate.eu, and we're developing this climate change service website. You should look on there for opportunities to bid for providing inputs to the service, but also for what the data store is going to look like and when it comes on stream. So I'll stop there. Thank you.
Thanks very much, Alan. There's a lot to chew on there, which we will do after 3 o'clock. So without further ado, Dickie Whittaker.
Martin, thank you very much. Good afternoon, ladies and gentlemen. The title of this slide talks about insuring against natural disasters. And indeed, I'm going to give you a perspective that comes primarily from how the insurance industry need to understand climate and weather. And for those of you who may not know, the insurance and reinsurance industry, I would say possibly is the largest consumer of weather and climate services in the world. And I'm doing that based on very little actual hard facts, but I think that probably statement is true. Not only that, but actually it's the largest single investor group in the world. And I hope that perhaps at the end of this talk you might have a perspective that the insurance and reinsurance industry is somebody that's worth interacting with because they're interested in this subject. And really I'm going to be talking about how we've created a tool called Oasis that is also a community that helps solve and translate weather and climate information into practical decision-making tools. And the agenda that I was asked to try and deal with was this, which is sort of, what is it? What's the benefit? What were the challenges? And what are the lessons learned? So that's what I'm going to talk about in the next 12 minutes or so. So first of all, as I've said, Oasis is actually an open source, plug-and-play piece of software that is both open and open source. So we give it away for free, at least if you're outside of the insurance industry. To actually get funds, we lent on our friends in the insurance industry to put some money up, so they sort of end up by paying. But for everybody else, it's absolutely free. And what it does is it's designed to incorporate some standards that mean that academics, SMEs, specialist firms around the world can parameterize the climate and weather information that they have expertise in, put it into Oasis, without having to understand how other components that the end users need are necessarily calibrated or built. So for a specific example, if you're a hydrologist and you believe that you have information about the current weather systems that could flood the Rhine basin, you could put that into Oasis. Somebody else, or indeed the same person potentially in collaboration, could say, well, actually, I understand what that floodwater will do to the built environment, so I'll collate a group of vulnerability functions that can be associated with hazard intensity. You then have somebody that could be the insurance industry, but it doesn't have to be, that puts either an insurable portfolio of physical assets in there, if it's an insurance entity, but it could be a city putting all their municipal buildings, or it could be a whole country wanting to understand, or everybody in the catchment, in my example, in the Rhine, wanting to understand what the frequency and severity of flood would be. So you put that into the engine, you select the type of analysis you want to do, and you get out something that gives you the frequency and severity on the assets that you've put in there. So it takes the science that we have state-of-the-art today and incorporates it with a built environment, damageability or vulnerability functions, and gives you a probability density function from which you can make decisions on particularly things to do with capital. So insurance companies need to do it because they need to understand if they're impairing their solvency capital. A city might want to do it to understand what their financial obligations would be in the event of a flood. So this is not specifically an insurance tool. I want to make it absolutely clear. So the other aspect of this that's really important is it's very transparent. And uncertainty was mentioned several times this morning. in our business, in the insurance industry, because effectively that's who I spend most of my time with, the treatment of uncertainty is absolutely critical in making decisions. In fact, a mean value is sort of the least important thing. It's the uncertainty around that mean that becomes really, really important. And it's one area that, in my experience, getting to Alan's point about where research needs to be and re-emphasizing his point, our understanding about how to treat uncertainty in this area is really pivotal and critical. Now, I should also say that this is used by every insurance, or tools like this are used by every insurance company around the world. And they're used for the current weather, extreme weather analysis. But of course, when and we have information that tells us about how our climate and weather is changing, you can of course add that in too, so that you can say, here is our estimate of current state and its impact, and here is the change based on many people in your room's expertise to inform us about what's going to happen as a result of climate change. So, and I realize this is slightly complex, but for the sake of the time we've got, I'm going to try and press on and hope that I've done enough to explain basically what it tries to do. It took us 2 years to build it, I might add, so it's not particularly simple. It's simple to use, but its construction was not that simple. So the motivation and vision. So why do we do this quickly? I think some of these things are important. So, well, first of all, we wanted to make it open and open source and not for profit, largely because we wanted the motivation to be clear as being beneficial to all communities, and we wanted to gain trust. And trust was mentioned a few times this morning. To me, it's been pivotal in us getting our message across. So hopefully that would develop innovation and it would create a sustainable environment. And we're sort of 3.5 years in nearly, and I would say that that would seem to be the case so far. We're growing quite quickly. Now, building a community was very, very important for us. Whilst we're not for profit at the heart, we firmly believe that the only way we are going to create a vibrant community is by having profit and people allowing to make profit. So I'll talk about the community in a second, so I don't want to go into too much on that now. Transparency, as I said before, extremely important. There are too many tools and products in the marketplace I am aware of where their lack of transparency creates huge problems in users being able to understand them and again creates this problem of a lack of trust. As it happens in the insurance industry, there is European regulation that requires the validation of these tools and models. And in fact, and also requires that they are proven to be used in day-to-day decision making. So this is really important for us. We wanted to create change. There was an existing the marketplace in this space in the insurance industry was dominated by two players who have approximately an 80% market share. Under those circumstances, you do not have incentives for change, for innovation, for transparency, and for competition. So all of those things were missing, and we wanted to try and create them. We thought it was important to have a quick phase development. There was discussion this morning, Roger mentioned it a few times, about this co-creation thing. I find that a little bit of a sort of slightly an odd phrase, to be honest with you, because I can't imagine why you would design something without getting two parties together. I mean, it would never occur to us not to do that. We do it frequently, we do it often, and it's absolutely fundamental. This marketplace is very important. Again, this is the profit sort of motive which we think drives this activity, and I'll come to that in a second. And lastly, but very important, is creating standards. We have looked at dozens of the models that use this type of paradigm. They're called catastrophe models. We've looked at dozens of these. Each one is done differently in almost every aspect. There is almost no consistency about how these models are produced by specialist firms and scientists around the world. Now, I would be the first to champion diversity, but that's too much. We are losing value by having too many versions of this. So by actually publishing, we publish a checklist of best practices, we publish lots of documents that talk about what that means, and that's helping to actually narrow the number of options that we have. And that, I think, is good for the developers and it's good for the end users. It makes the whole process easier and cheaper. So just briefly, 2 slides on the community. I don't want to dwell on this too much, but it was really important to get buy-in and money from the people that were most going to benefit in the short term from this is the insurance industry. So to date, about 44 companies have invested in Oasis. They actually own it. I have no shares at all in Oasis. And there's just a list. So the point is, and they represent companies all around the world, and I should say there's one honorary non-insurance company here at the top of the list, which is Climate Kick. They were one of the earliest organizations that helped us get on the road. So in fact, they get a sort of honorary seat here, and in fact, they have a position on the board as well. But really importantly, it's the supplier community that would make this live. And here is a small selection. There are about 100 associate members. There's no charge for doing that. Here is just a small selection of providers from around the world who wish to get their knowledge, their intellectual property, their technology into the end users, and they see the value of using Oasis to do that. And I can't underestimate how important this is. So effectively, this is the distillation, this sort of translation function, the creation of standards. You don't need to understand the language of the end users because we provide all of that, and some of these people and many more get the benefits, hopefully, both financially and many of these, of course, are research institutions too. So there's a lot of research potential you can get out of this as well. So what sort of challenges did we have to overcome? Well, more than I thought, I think, is the first thing I would say. And to go through this quite quickly, because I'm sure I'm probably coming pretty close to the time. So first of all, we thought by setting out these standards, by writing some documentation, by giving away the software, the academic institutions and SMEs that were experts in climate science would be able to easily parameterize their models in a way that would work easily in this format. And the answer is, in many cases, they couldn't. And the particular reason why they couldn't, there are two reasons really. One is that this issue about the treatment of uncertainty. Many just found that just very difficult to do, and there's very little literature out there that helps them do it, which is very frustrating for us. The second one is you need excellent statisticians in this space. And we often found we would get fantastic hydrologists, fantastic meteorologists, but not always combined with excellent statisticians. And the actual distillation of this into what is effectively a statistical package, you require very high quality statisticians. So it was a bit of a problem for us. There was very little openness from the existing players, but I've sort of mentioned that, I won't go into too much detail there. This issue and somebody mentioned this morning, which I thought was really interesting. The reason I think that we have been successful is a combination of sort of 3 or 4 factors: understanding the market, understanding the science, taking a leap of faith and actually trying to get this done, being very agile in how we did things, but actually critical for us was having the best IT knowledge. I've seen so many situations where really good science, really good ideas have been ruined by having poor IT delivery. And actually it's a challenge because you need all of these things at the same time in the same place, in my experience, to make these things work. And lastly, you need money. And I don't think anybody's mentioned the money before, but it's really important. At the beginning of every single year, I never knew how I was going to pay all the staff by the end of the year. We just had to find some way of doing it. It's always an issue and it's always a challenge. So, what are our lessons learned? Well, I think that somebody mentioned open data. The power of open data, open innovation, and open source, don't underestimate it. I've been completely convinced in the last few years. Understanding of your end market needs. If you do not absolutely understand in the highest level of detail what your end user wants, please find somebody that can help you get that information, because I don't think it would make any sense not to. The standards are important. I don't want to talk about that. These small steps and test it with users, that's almost certainly the case. The only thing I would say is, and the sort of Henry Ford analogy of, if you ask people what were they going to do to get a better horse, they'd say, I want a faster horse. We've had at times to make decisions where we've said, the users have said, don't understand what you mean, don't understand why you want to do that. And we've said, we think that's going to happen, we're going to take a leap of faith. So occasionally you have to sort of beat that. And then you need a combination of all these things, and I've talked about that, so I don't think I have to go over that. All of that for us produced a situation where after 2 years, we launched the software at the beginning of last year, and we've only actually put out one press release, and it sort of went viral and all of a sudden people phoning me up and going, how on earth did you get publicity all around the world for what you did? I don't quite know the answer to that. All I know is that when you get something right and the motivation's right, people talk and actually things happen that sort of make sense and have value. So I want to add one thing in conclusion. There was a point made this morning by the lady talking about what BASF does. And I was fascinated by how they're trying to downscale global circulation models to be able to look at information at a particular plant in a particular location. The insurance industry performs that analysis every day and will be doing so for BASF. They use these models and these techniques to do that. And I'm not saying it's the only answer in every situation, but it is a really robust, common way of getting analysis on the frequency and severity of natural catastrophes and the impact from climate change. So what I'd say is, when you next think about doing something, think about the insurance industry, think about Oasis, and think whether or not you can be getting utility for your jobs and your science into our environment. So thank you very much.
Thanks, Dickie, very much. So a great example there in the specific area of insurance. And now Stephen Belcher from the Hadley Centre of the UK Met Office.
Thank you, Martin. I feel I have a confession to make, which is that I'm a climate scientist. I'm not a user. So Martin is booing me on that basis alone. So I think I'm here to talk about a perception of how climate science can address some of the needs we've been hearing about, but also drawing on the experience of the Met Office, and within the Hadley Centre, we've been developing and delivering climate services for a while, and my colleague Chris Hewitt's been leading that. Okay, so climate science generally, there's clearly a shift now away from assessing long-term trends. The real achievements of climate science over the last 20 years has been to establish that the climate is indeed warming, and that human activities are indeed a major source of that warming. So to some extent, the first two questions of climate science have now been addressed and solved, and therefore the science needs to evolve. One of the things that I would say frames our evolution is to think about the hazards that the climate can throw at us. So thinking about a risk-based framework, what my community provides, I think, is the hazard and how that hazard might change in the future. And then the users and the purveyors are there to establish the vulnerability and the exposure to that hazard to calculate risk and so on. So we hear quite a bit about extreme conditions bringing climate to the fore, weather to the fore. And I'd like to just slightly refine that view. It's one of my messages in this talk. So firstly, I would say something that we can, in climate science, give some view on the future and how it changes is on what I would call climate events. So these are climate events that are seasonal in duration and regional in extent. So I'll talk about the summer heat wave in 2003 over Europe as an example of such an event later. The second thing that maybe we can just about begin to address is how high impact weather within these climate events changes in character and frequency, and this is really emerging science. So I guess I partly labor this at the beginning to caution against plant-specific locations and very highly detailed specific locations. I think that the science community is thinking about robust understanding and projection of these climate events initially. As Alan Thorpe did, I'll frame the talk around the past, present, and future. And I hope in terms of the roadmap that we heard about this morning, there's at least strengthening the science base, but there's also some market establishment here as well, I think. Okay, so when we're thinking about the past, of course, it's climate variability as well as change that we need to assess. And the purpose of looking at the past is to establish vulnerability. We know now that the past is not a guide to the future. Nevertheless, for many areas of the world, just understanding what the past has thrown at that location and how that location has coped with those weather events is a very useful first step in assessing vulnerability to climate and weather events. So the kind of things that are happening in science in this, as Alan mentioned, we've got a constellation of new satellites going up, which will give us unprecedented coverage of a range of new climate variables. And it's really the novelty of the climate variables that's new here. So rainfall in particular will be measured in an unprecedented way with these new constellations. And I think rainfall at the moment is the poor relation of the data that we're able to capture about our planet. And yet it's clearly one of the metrics that delivers most of the impacts of the climate system. So satellites provide new data. These data are ingested to provide a best estimate of the past. So in the jargon, this is reanalysis, will be familiar to most of you. So one of the deliveries of the Copernicus system. There's a growing interest in regional high-resolution analyses. So there's a Framework 7 project called UERA, which is developing this reanalysis over Europe. And what we're seeing through that is that things, particularly rainfall, we have much higher spatial information on that and much more detail about where the heavy rains are coming. So again, this is really, I think, on the past climate where the excitement is coming, which I hope will feed into the Copernicus system. The present day is often not talked about very much, so this is perhaps the second message I'd like to offer you in my talk. So if we think about the summer 2003, that isn't quite today, it's 10 years ago, we need some memory to remember it. But as the top right diagram shows you how much warmer it was in the UK, and over many parts of Central Europe, it was much warmer, so 10 degrees warmer over June, July, August average. So it was really an exceptionally hot summer. In fact, the hottest since 1540, I'm afraid. Forgive me, I'm a weather geek. We like these statistics, of course. So certainly in living memory, it was the hottest summer that we've experienced. So a first thing that we get asked is, to what degree did climate change contribute to the risk of that event? So there's a question of attribution. To what extent do greenhouse gas emissions contribute to that warm summer? So there is an area of science called attribution science, and we run the simulations with measured emissions of greenhouse gases and then with pre-industrial emissions of greenhouse gases, and we assess how the risk of an event like this changed because of the emission of greenhouse gases. So through work like this, colleagues of mine at the Hadley Centre were able to say that the odds of the 2003 summer heat wave were doubled because of emissions of greenhouse gases. So we have an event here which we can connect very clearly to emissions of greenhouse gases and part of the climate change story. So it acts, I would say, as a trigger and an interest in climate and therefore potentially climate services across a range of sectors. By providing the attribution statement, the fact that the odds were doubled because of greenhouse gases gives us a hint that this may well continue into the future. So in my plot here, the graph goes from 1900 out to the end of the present century, 2100. The black line are the measured data for European summers, and we've got simulations of the last century and then projections for the future. So the summer 2003 is the spike here. So the other thing we can do is to assess what's happened over the last 10 years. And what you see from this plot is that temperatures in European summers have continued to increase over that period. And that's worth emphasizing because this is a period where famously the global mean temperature has remained flat. So there's been a lot of debate, at least in the UK media, about whether climate change has stopped. Well, if you're interested in these more local events, here is very direct evidence that it has not. And in fact, the trend continues at the top end of the projections. So it seems to me that in terms of a package of how we can package the past, present, and future, focusing on events like this could be one way of doing it to trigger interest and form a package of information to stimulate some climate services. It may be that this isn't an event of interest to you. Maybe it's the minimum in Arctic sea ice, because that opens up shipping routes, or other things like that. Or it may be the hot summer over Russia, which killed wheat harvests over there, or it might be the hot period over Australia. So globally, we can look with our models and our data at these extreme events and put together this package of information. This is early stage science, but I believe it is possible in the medium term. I shall leave that, I think. Okay, so future projections, and I come to my third and final message of my talk. So we've heard a lot about projections and the use of them in some of the sectors we heard about this morning. We heard from Alan that the Copernicus system will include projections a season ahead, and there are many climate services that are delivered using the seasonal forecast. So in the Met Office Hadley Centre, we have a very big partnership with Chinese climate scientists, and they're very advanced in their provision of climate services, but they're almost entirely centred around seasonal forecasts, actually, for agriculture, the water industry, etc. So building trust and skill in these seasonal predictions, which are notoriously difficult for Europe, remains a priority. We heard this morning quite a lot about the 1 to 5 year timescale. So there is a new science emerging of so-called decadal prediction, a misnomer, I'm afraid, but it's decadal and it goes out to 5 to 10 years. And this is using information about the current state of the climate to give a better indication of what might happen over the next 5 to 10 years. At the moment, I would not bet my pension savings on a decadal forecast because the skill is not there right now. But again, there's tremendous opportunities for scientific development here. And then finally, I want to end on the multi-decadal projections. And here, I think there's both an opportunity and a threat. So the threat is the confusion of a model simulation being a prediction or a projection, and it's not. So the international community organizes the simulations of climate models into the so-called CMIP archive. So it has hundreds of climate model simulations. Those hundreds of climate model simulations are not a projection. And they're not a projection because it's a range of different models, and you don't know which one's good and which one isn't. All the models have various biases in them, and if you're a user, you won't know that, and I don't know that. So these biases have to be corrected out. And furthermore, this random collection of simulations doesn't give an honest representation of the spread in these projections, and therefore doesn't build trust in the confidence limits. So I think there's a science area that at the moment the EU is slightly missing, which is to build projection systems out of these climate simulations. So there are scientific techniques for doing that, to weight the different simulations by how they perform over the last 50 years, how they perform on other metrics of known climate. But it's this weighting to form probabilities that give proper spread onto the projections, which I believe is really missing. And in that spirit, I would like to suggest that an authoritative set of projections could come about if we as a community joined together and made an EU climate projection system that produced a trustworthy set of projections for the European community. We have such a thing in the UK. Various other EU nations have them. We all use different methodologies. We all argue about which is the best. There is no consensus view in Europe. It's like other aspects of Europe, perhaps. My near final slide, if I may, is to just touch on, I've talked mainly about climate events there, regional in extent and seasonal in duration. Let me just say a few words about the high impact weather that sits within those. So we've started doing some work at the Hadley Centre where we're using our very high resolution weather forecast model, which partially resolves thunderstorms. That's the innovation, rather than treating them in a different way. And we've been able to run some climate change simulations using this model. It's fantastically expensive computationally. But what it's shown is the character of the very high rainfall events, so the top 5% heavy rainfall events, changes in a future climate. So because the physics of a warming world holds more water, we know there's more rain to fall out when it does rain, because there's more water in the atmosphere. But in these thunderstorms, the nature of the storms changes, so you get an additional increment on these very high rainfall events. So I think the science is just beginning to open up on these high impact weather events for how the character of those might change and possibly also the frequency. But again, early days work, and I think a real concerted European effort for different regions of the world could really do something here. And you could see there's a range of impacts. Flooding is one, drainage in urban areas, soil erosion, high wind events is another. Okay, so just a few words of summary. The kind of data, as the Copernicus system exemplifies, is about the past, the present, and the future, and there are ways that we can bring those things together. Rather than talk about extreme events, I'd like to talk about climate events and then the high-impact weather. I think extreme's a bit lazy, and we need to be clear about what we mean by that, because I think users of climate services want to be clear about what we mean. It's clearly about climate variability and change. Not all of the extreme seasons we experience in Europe are due to climate change. We had a very wet winter, 2013-14. That was almost certainly largely due to natural fluctuations in the climate system, although there may be a small climate change signal. And then finally, I talked about the range of projection systems that we need for the future, seasonal, decadal, and then multi-decadal. And I offered up this challenge of an EU climate prediction system to convert climate model simulations into genuine projections of the future. Thank you.
Thank you, Stephen. That's great. Thanks, Stephen, very much. That's also given us a lot to think about in discussion following. So, Daniela, last but certainly not least, and a member of the expert group that worked on the road plan.
Yeah, thank you very much. After all these beautiful talks we heard before, I would like to share with you some thoughts of concern, or let's put it, challenges. Maybe it's a bit more motivating. I have just listed here a few sentences and bullet points which I think deserve some deep thinking and some help to overcome those problems. I would like to talk a little bit about data, products, information, and methods. We haven't heard much about human skills needed in climate service. We have even heard less today about some legal issues. And we heard a little bit about resources. I heard the word money before, but I'm not only talking about money. What I share with you here is based on, of course, the discussions which we had, or it's partly based on the discussions which we had in the expert group and with the support group. It is based on the discussion with the regional climate modeling community in depth, who is often very close to the end user when it comes to the need of data. It is based on a workshop from the European Climate Service Partnership Network, which we had last week in Hamburg, about how to approach or communicate with a stakeholder successful. And it is, of course, based on our own experience. So we heard that we need open access data, and I also heard that for some data the issue has been solved. The Copernicus Climate Change Service said they will be freely available. It is very important that the availability is open and that the access is easy. So we need the information for data, products, information, and methods on different levels and different scales in order to know which data can we find where and how can we use it. And I'm not only referring here to climate data, but climate services need many more data. We heard a little bit about the insurance just before, but it stretches into many different disciplines and socioeconomic and business data. I think it is a bit unclear how the ownership is situated. So the ownership for the different products, the data, the methods which will be used for downstream climate services To whom should I refer if I use a specific methodology which I need in order to tailor my product to the end user needs? I think the clear ownership is key. It is still unclear what is possible when it comes to commercial use. We heard before about the data, but as I said, there are many data sitting at, let's say, local or regional administrations, which are important for spatial planning issues, for example, which you need when you want to do a successful adaptation, for which, again, you need a climate service. And when it comes to the strategic development of businesses, there's, of course, confidentiality involved. And here also we need a kind of a protocol or a way to work with this on both sides, for the provider side as well as for the user side. There is still a question about accuracy, quality control, and evaluation. I haven't heard much today about the evaluation of climate services itself. I'm not talking about the institutions. This is a kind of an easy job. But the products. How do we evaluate the added value of the product? How do we know if the demand has been fulfilled, if it is useful? We need kind of an evaluation methodology, a protocol, and who actually is doing this? We had this morning. This topic was touched a little bit. And who is evaluating the climate services themselves? It's an interdisciplinary approach often, so again here, we have to rethink about criteria. We can't just count like scientists are doing by the number of Nature papers. This is not really what's needed when it comes to the family doctor, as we had this morning. And I think we talked already about standards, which are on their way, especially when we talked about a growing market. We need standards for methods, how to use the data, how to address uncertainty, and who actually evaluates the quality of all the activities in the growing market of the private businesses, for example. Would you say if the business is successful, the climate product was successful? I doubt that this is all we can do. Let me talk a little bit about human skills. Who is doing climate service? There is no educational profile. You cannot study climate service somewhere at the moment. We have a diversity of disciplines involved, the diversity of providers, producers, analysts, communicators, evaluators, financiers. They all work together, but it is fully unclear how much they have to know from each other, what the skills of the individuals are, and what kind of expertise and knowledge is needed within those providing climate services across disciplines for the evaluation. I just remind some of you how difficult it is to evaluate an FP7 interdisciplinary project. So there is a new, I would say, a new field where we have to think also on the educational aspects a little bit. There's also a question about, on the user side, how much should I really know about the product I'm buying? How detailed should the information be for the product I'm using? And versus the approach of the co-production and the co-design. If we go along those lines and go along the co-production, co-design, then we have different cultures working together, which is challenging, it's interesting, and it's pushing, it is for innovation. But I would say there are a couple of users out there, end users, stakeholders, who would say, I'm not really interested in the details. As we heard this morning, I have 5 minutes to take a decision. So how much of the information and knowledge exchange is really needed, and how much of the mix of the disciplines is needed? Which skills are needed? And of course, within the climate service providers themselves, it's unclear how the career options are. if we want to create jobs and attract people, we need some good business cases and demonstrate that it makes sense to start an SME on climate services, that there is a market and that there's a career option. Let me talk a little bit about legal issues. Within different countries, not only in Europe, but in Europe, there are conflicting legislations. This might hinder some of the climate services being used, at least on a wide European scale. Legal aspects are also needed for the ownership. We talked about this before, the co-design, co-production. Who owns the product? The non-commercial and commercial use, confidentiality, this can be regulated, I would say. Responsibilities are sometimes still unclear. It is unclear who is responsible for which part of the product development, or for the implementation, or for the use. So where are we situated in this legal frame? Sometimes a political commitment is needed, sometimes it's missing, sometimes it is changing while the product is under development, and there are, of course, time frames and different timescales which we heard about. The liability is unclear for several of the products, at least when it comes to products or climate services where data and methods from very different entities and kinds have been used and mixed into a final product, or when you look at the full value chain. So I think there are some issues which hinder a little bit the dynamic in the market, which I think would be worthwhile to address, and I'm sure some are missing. Finally, let's think a little bit about the resources. When we talk to end users and ask them, why haven't you engaged much more in our climate service? We haven't seen you at our stakeholder workshops. You haven't offered a co-design or a co-production, not even the financing for this. They often say it's lack of financial and human resources, it's lack of time. So I think we need to develop a common approach or a common understanding for the different interests and sometimes conflicting values for the user side, the demand side, and let's put it, the climate serving side. So the different expectations between providers and users can only be resolved through dialogues and knowledge exchange. And this, of course, is time-consuming, and it needs a treatment of both sides on equal footing. So I think here, the clear information about the economic impact, as we had this morning, is often still unclear, and an advancement here would be helpful. So let me summarize. I know that these barriers are not the only ones. There are probably many more. Some can be overcome very easily. Some will join us for the next couple of decades, I think. But I think it's very clear that we need open and easy, accessible, quality-controlled data and products, and I heard some promising steps into this direction, at least from the climate products, climate information, but we need more. The clarification of human skills, the capacity development, and the career options are very important to attract people and to help building new attractive jobs. Responsibilities, engagement, and liabilities have to be clarified and specified. And the expectations, the economic impact, and the resources have to be adequately considered. Thank you very much.
Thanks, Daniela, very much for wrapping up for us so well.